Over the last few years, technology has given us many, many gifts. That cell phone that you're holding in your hand, that's all thanks to technology. Your air conditioners, cars, microwaves, refrigerators, stoves, all products of technology as well. Heck, even this video you're watching right now is a product of technology itself. And as year after year passes, scientists and developers all over the world find a way to make all these products of technology better, faster, stronger, smarter, and just all around better. Today we're going to be talking about one of such technological advancements, and that is quantum computing. This is Fraud Explained. To enjoy more of our videos, subscribe to our channel and click the notification bell, or else I'll be looking into you too. Technology. Thousands of years ago, our latest forms of technology were limited to the tools we had around us. Tools that we needed to hunt, to build our homes, and to basically survive. However, over the years, technology advanced and developed, and it has helped us reach frontiers that we were once only able to dream of. One of those advancements? The computer. The first computer that resembles today's modern machines was conceived and designed by British mathematician Charles Babbage in the years between 1833 and 1871. Over the years, a computer was developed and calibrated to turn into the modern flat-screen versions of it that you see today. Computers are able to do many, many things. You can research, calculate, and organize with just a few clicks and a press of a button. However, humans are all about surpassing their limits, which is why in 1998, Isaac Chuang of the Los Alamos National Laboratory, Neil Gershenfeld of the Massachusetts Institute of Technology, and Mark Cubanek of the University of California at Berkeley created the first ever quantum computer. Whoa, but hang on, wait. What exactly is a quantum computer? First, let's dive a bit into quantum physics. Quantum physics is able to describe and identify the behavior of atoms and fundamental particles, such as electrons and photons. It is one of the most successful series of modern science in that quantum physics is able to describe the way that our world works. At its most fundamental level, quantum computing has become one of the most prominent and one of the more important applications of quantum physics. Quantum computing happens when you use quantum mechanical phenomena, such as the principles of superpositioning and entanglement, to perform computations. Quantum computing would be able to solve complex problems and conundrums that the most efficient and most powerful supercomputers of today would not exactly have an easy time doing. So basically, what a quantum computer does is it controls the behavior of these particles, but it does so in a completely different way from your normal everyday computer. To give you some sort of mental imagery, try for a moment imagining a bicycle and a car. Both vehicles can get you to places, but to compare one to the other is unfair. They are worlds apart. They're not operated in the same way. A bicycle is a bicycle and a car is a car, the latter being a way more complex piece of machinery than the former could ever be. Cars are way more efficient machines. That is what it is like for quantum computers and our everyday run-of-the-mill computers. Scientists believe that quantum computers have the capacity to change life as we know it. Their technology could be used to uncover numerous developments in the field of security, healthcare, and, well, technology itself. As such, multiple companies around the world are scrambling to build their own version of these devices. Watch on to see how quantum computers are used today. Technology giant IBM, or the International Business Machines Corporation, prides itself in being the most passionate institution in the field of quantum computing. The company is headquartered in Armonk, New York, with branches and operations in over 170 countries. It specializes in computer hardware, middleware, and software, and provides hosting and consulting services in areas ranging from mainframe, computers, to nanotechnology. IBM is also a major research organization, which is why it's not a surprise that it is one of the frontrunners in developing the technology used for quantum computing. But wait, we're going a little bit off topic here. Let's dial it back a little bit and look at the basics. What are computers made of? A computer is made up of very simple components which do very simple things, represent data, the means of processing it, and control mechanisms. How are computers able to process data? Well, computer chips contain modules, which contain logic gates, which contain transistors. Transistors are the most basic form of data processors in computers. They can choose to either open or block channels that allow information to pass in and out. Information, on the other hand, is made up of bits, which can have a value of either 0 or 1. If you have a bunch of bits and combine them, you will be able to represent more complex information. Once a chain of processes goes through, it will be able to dismantle all the information throughout your computer and let you do virtually anything you want to do with your computer. Logic gates can be used to add and multiply numbers and data, which would allow you to perform basic operations on the computer. However, because scientists and developers have been trying to make computers smaller and more compact while still performing at maximum efficiency, the smaller and smaller parts are made even trickier with quantum physics. In the world of quantum physics, the computers as we know them today just stop making sense, mostly because they're not calibrated or equipped to handle the processing that quantum computers can. Instead of bits, quantum computers use qubits. Qubits make it possible to store and manipulate a vast amount of information by using a relatively small amount of particles. Qubits are anything that exhibits quantum behavior, contrary to our computers whose bits are made up of thousands of tiny transistors. Qubits make use of two key principles of quantum physics: superposition and entanglement. Because of superposition, qubits can represent either a 0, a 1, or even both simultaneously. Entanglement is what occurs when two qubits in a superposition correlate with one another, meaning the identity either qubit takes on is entirely dependent on the state of the other. It is a much more complex processing system than your standard computer because it does not use the same type of switches that are present in classical computers. Because of that, quantum computers are able to solve problems that are virtually unsolvable on regular computers. So what exactly are quantum computers good for? While they may not replace your trusty laptop or desktop, they are infinitely more superior in other aspects. Database searching can be done in a fraction of the time it would take you to look up something using your computer. Here are 3 other things that can be further improved and developed using quantum computers. The first is biomedical simulations. Medicine and healthcare would certainly be able to go a long way by using quantum computing. Using quantum computers, scientists and researchers would be able to create, simulate, and model different types of molecular structures. In 2010, researchers at Harvard University were able to use a D-Wave 1 quantum computer to figure out how proteins fold. It was able to show the researchers different mathematical representations of the enzymes. While the technology was not perfect, it was able to somewhat accurately model the behavior of the protein folding. With more development, scientists would encounter more breakthroughs and may be able to uncover more on how the world works. The second is financial services. Quantum computing is finding a foothold in the realm of financial services. An example of this is D-Wave, a company backed by Goldman Sachs and Bezos Expeditions. D-Wave deployed its very first commercial quantum computer, the D-Wave 2000Q, a quantum annealing system with 2000 qubits and advanced feature controls. Even though these devices are incredibly expensive, these computers are being utilized by a small niche. The systems could be used for complex financial modeling and risk management within the financial industry as well. They would be able to model simulations of the financial industry and allow people to basically gauge what would happen next. And last, but most certainly not least, machine learning. In manufacturing artificial intelligence, the software needs to be able to extract huge amounts of data in order to be able to efficiently and effectively work the way that they are supposed to. There are huge amounts of data just waiting to be discovered, and quantum computers would be able to accomplish just that. Artificial intelligence would benefit greatly from this because quantum computers would be able to feed them the data that they need. Why is it important to develop this technology? Quantum computing is arguably the best path to creating ultra-powerful computers that would allow us to solve unimaginable difficult problems that not only affect technology, but even the world as we know it. As our need for powerful processors continues to increase due to advances in technology, and the problems that come with that become larger in scope and complexity, we would be needing this type of technology to address such problems and advance even further. So what are your thoughts on quantum computing? What do you think quantum computing could do for the human race within the next few years? Which field do you think would benefit from it the most? Let us talk about it in the comment section below. I'll be sure to respond to every comment that's posted within the first hour. If you enjoyed this video, head on over to our other video called The $1 Trillion Story of Amazon to find out how Jeff Bezos, the creator of Amazon, was able to build his empire from the ground up and become one of the only 2 companies in the world that is worth $1 trillion. Stay tuned, stay educated.